right, so we're going to start talking about mean and median today, which you might want calculators because we might be adding up data and finding them. It's just adding and subtracting, you're fine. All right, so when we talk about the difference between mu and x bar, first of all, this is mu. Okay. It's better than physics, though. Okay, so mu is basically the average for the population. No. I just need to know what it is. Okay, so, focus, children. Mu, boys, shut up and focus. So, mu is the average for the population. Now, that is the big thing, is it's population. It's everybody. So if you don't know that it's for a population, you have to assume it's for a sample. And that's where x bar comes in. So this is pronounced x bar. Right? X with a bar on the top. Oh no. Alright, that's going to be your average for a sample. Alright, now you will see different symbols at different times on the homework. You have to know that if they switch and they go from mu to x bar, they went from average for the population to average for the sample. So that's going to change what we look at for standard deviation as well. That's a tomorrow problem. Okay? So, what are resistant measures? Alright, start with what's a resistant measure anyway? Okay, example of resistant. Freshman. When any adult comes in to help a child with something and they're like, you're really mean. No, I don't put up with you acting like a hoodlum. Dear God, if you're in high school, make it stop. That's resistant. Fighting against whatever you're supposed to be doing. It doesn't matter. You could walk in and give them all the answers to the test. Screw you, they don't want to listen, right? That's resistant. So a resistant measure is something that's going to be, basically, it's difficult to move it. So for an average, what do outliers do to averages? Move it. A lot or a little? A lot. One outlier can skew and mess up your entire average. So a resistant measure is something that won't be impacted by outliers. All right. And mean is not resistant. All right. If we did average, I don't know, salary in the United States, and we included Warren Buffett in there. You guys know who Warren Buffett is? Stupid rich guy. Not Elon. He's actually kept all his money. All right. So Warren Buffett, if you took him and put him in with the average of every other income, he's going to take that average and he's going to drag it towards the really rich, right? Because he's stupid rich. Mean is not going to work for this. The one that will is going to be your median. What is median? It's the actual middle number, okay? So median is going to be your middle number. Yes, median is resistant. All right, we're going to have to get rid of those cats because whatever's in the lower right-hand corner is going to give me nightmares. First of all, it has 5 legs, which is an issue to begin with. Second, it's got like 6 stringy little mustache things that are all touching the floor. Sketchy. I know. We'll erase it here in a minute. All right, so for this next part, it says, how can you estimate the mean of a histogram or a dot plot? So the easiest way to kind of do this is to look at the skew. So sorry, we're bringing up the toes again. My bad. You're going to be fine. All right. It is a little bit like a roller coaster, except there's brakes in it. Is that squiggly thing? Yep. So this one is skewed to the right. Yes. Kind of look like right toes. So mean is actually going to be pulled towards your outlier, because the outlier is going to be over here. All right. Your median, which I did in purple, is going to be closer to the actual middle of where all my data points are. All right. If it's a normal distribution and there are no outliers, where do you think mean and median are in relationship to each other? About the same spot. So, median, they are pretty much close to being the same. Samesies. All right, same thing happens if it's skewed left. Median, pulled towards where my outliers are. So this one would be, okay, what's the average salary for NFL players? And you've included, is Baker still even on the team? He's technically on the Rams. Okay. Baker Mayfield. I'm sorry, I'm gonna hate on Baker. All right, so if you have one random player who's not making any money, but you've got everybody else who's over here making millions, that one outlier is going to pull your mean down. This is also what typically happens when you have a test. All right? Averages, pretty good, pretty good, pretty good. Crap the bed. All right? So it takes your test grade and it just drags it towards where you've pooed the bed. Okay? Yep, everyone does really crappy. One person does great, pulls that average up. Yes, you guys might have been more at this one. Outlier here, everybody else right here. All right. So, up next. Is median a resistant measure? We said yes. Okay. All right, and I would say yes, and simply because it's the middle number. So one outlier on either side's not going to pull it too far. It does protect against outliers. Yeah. All right. How does the shape of the distribution affect the relationship of the mean and median? See above. Alrighty. So, what's range? Yeah, biggest minus smallest value. I was loving the charades of range, because like half the class goes like this with their hands, like it's this. All right, biggest minus smallest. And then do we think range is going to be resistant to an outlier? Because we're outliers. Yeah, one of the outliers is typically going to be either the biggest or the smallest. So, not resistant. And I would say because outliers are typically the biggest or the smallest. All right, so far so good? All right. Oh. All right, what about quartiles? Do we remember quartiles at all? Yeah, it's 1/4 of your data set. All right. So literally when it says how do you find them, you have to list all of the values out in numerical order, figure out where the median is for half, and then split each side in half again. Or you can do it within the calculator using one variable statistics. So 1 var statistics. All right, so most of the time, especially with like a box and whisker plot, yeah, remember these things? So this is quartile 1, this is quartile 2, this is quartile 3, and this is quartile 4. Yep. No, you're not. No. See, the luxury is if you have your data in the calculator, it makes this stupid easy because it'll find everything for you. All right. Now, interquartile range, IQR. Okay, this is found by taking, actually, let me just do it this way. Honestly, I taught this in 6th and 7th grade. Yeah. I'm almost done, I promise. All right, so IQR is found by taking quartile 3, the end point, minus quartile 1's end point, which is really just the start of quartile 2, but it's just, yeah, it's the front of the box minus the back of the box. That's it. All right. Now, what do you think about IQR? Would IQR be a resistant measure of spread? Why? Where are the outliers? Yeah, outliers are going to end up being outside, like Q1, Q4. So IQR does end up being a resistant measure of spread. All right. So, do you guys want me to show you how to do all this in the calculator? Okay. So, grab your calculadora. McDonald's? Yeah. Well, because it's got the Mick in it, so that makes life easy. All right, so, real quick, they give us 9 different data points, and we're going to go through, and I'm going to show you guys how we do like a whole box and whisker plot, how we prove whether or not something's an outlier, but with only 9 data points. Okay, so how do I get it so I can enter a list of data in my calculator? Stat, just edit. How do I clear out old data? Up and clear. Up and clear. Stat is right by the left arrow. It's the first thing that's in there. Just click stat. There it is. All right, ready? So, did we all get it cleared? We have list 1. It's showing up. We're good? All right, so now we got to enter our 9 data points. Numpad. No, I have a numpad over there. I just go and type it. All right. How am I sure that I got all my data points in there right? L10 should be blank, so I know it has not gotten to that 10th data point. All right. So, real quick, to show you guys how to do one variable statistics, hit second, quit. All right. Now we're going to hit stat, and we're going to go over to calc. 1 one var stats. All right, that's saying one variable statistic. Now, depending on how old your calculator is, it might ask what list it's in, what frequency list, calculate. Does anybody's not show that? Does anybody's not look like this? All right, so easiest thing ever, just go down to calculate because everything's in list 1. Hey. So, notice it gives me a whole bunch of different information. Okay, the first one is X bar, which is what? Sample average. So the average fat content for these 9 sandwiches is right around 20 grams of fat. Okay, now, yeah, that crispy chicken, yeah, we ain't playing with that one. No, it's all the fat content in the ranch. So notice down here, see how it says n equals 9, number of data sets. All right, then it gives me my minimum. Then it gives me Q1, median, Q3, and my max. So if you had to do a box and whisker plot for this, all right, you would do it on a number line. So I'm going to make a little number line. So I've got, I don't know, where do we want to start?
9.
Well, let's start at 5. Yeah, we're gonna try and like measure it all out. 5, 10, 15, 20. Yeah. And then if you have to do a box plot off of this, remember, the 5 numbers I need for the box plot are right here. Min is at 9. Q1 is at 15. Median is at 19, 24.5, and 33. So here's how I do this. I go to 9, draw a little line. Go to 15, draw a big line. Go to where I estimate 19 to be, do another big line. 24.5, big line. And then 33, little line. 3 bigs make your box. 2 littles are your whiskers. It's kind of an estimate. But if you've got your final one at like 33. Yeah. So what do you notice about it though? There is a box, yes. But are the whiskers the same length? Are the boxes the same length? No. All right. So I've done all this. All right. It says calculate the median and the IQR. Well, luckily, if you do it in the calculator, the median is at 19. And then IQR, we said this one was at, what, 15? And this was at 24.5. So IQR, what was it, 9.5? Yes? Bueno? IQR is end of Q3 minus the end of Q1. All right, so this next little chunk says, what's an outlier and how do you identify it? All right, so when it comes to an outlier, you need to be 1.5 times the IQR away from the edge of Q3 and Q1. So that makes absolutely 0 sense. Let me show you. All right, so we've got low outliers, and those are going to be found by taking 1.5 times your IQR, and I'm going to subtract that off of Q1. Okay, so what is 1.5 times, what was it, 9 something? 9.5? And we said it was 15 minus, what was it? 14.25. And that is 0.75. Do I have anything lower than 0.75? Q1. So it says Q1 because that's where that box starts. It's really the end of the first 25%. So do I have anything on the low end for outliers? Nope. All right. High end. 14.25 is 1.5 times this. Just accept that the 1.5 is how we determine outliers. Honey, old math dead dude decided this. Yes, the 1.5 does not change. It's always the IQR based off of your data set and then wherever those quartiles start and end. All right, so high outliers are going to be Q3 plus 1.5 times your IQR. So we said Q3 and was at 24.5. And I need to add that 14.25 to it. What's that give me? Like 38.75? So with that initial set of data, did I have anything that's bigger than that? No. So when it comes to finding outliers, you're looking for numbers that are smaller than this and numbers that are bigger than this. All right? If they are not smaller than it, they're not an outlier. If they're not bigger than that, it's not an outlier. So the easiest kind of way to remember this is it's always Q1 minus 1.5 times your IQR, and then Q3 plus 1.5 times your IQR. All right. So, do you guys want to try running the one variable statistics for this slightly altered data set? More McDonald's crap. All right. Hit stat. Yeah. Eventually. It is. All right. So run your one variable statistics on that. Yep, we're going to do the same outlier thing. If you want to try it on your own. Nope. Where are we at? So, then we got to talk. You got to add to go for the bigger ones. All right, so I got minimum cutoff is 9, max cutoff, because 8's your IQR. Yeah, I did. It's Q1 minus Q3. So this is finding the IQR. This is outlier check. All right. Give me 1 second, let me finish. All right, so we said our IQR was 8. All right, so the low end, do I have anything that is less than 9? No, but I got one that's equal to. I clicked purple, you stupid thing. I hate you. Okay, just didn't want purple. All right, so with hamburger being at 9, you could consider that like right on the edge of being an outlier. If you argued it on your paper and said, okay, hamburger could be and you could just say because 9 equals 9 and it's right at that cutoff. All right, and then the other one I have is 41. Do I have anything bigger than 41? I have 43. That double quarter pounder with cheese is definitely considered an outlier. So, double quarter pounder plus cheese. So a double quarter pounder is 2 hamburger patties. Yeah. All right, so. No, if you said the hamburger's not an outlier because, are you guys listening? Because your test is next week. Might want to listen. Ooh. So, the question was, if you said hamburger is not an outlier because it's right at the cutoff, I would not be angry about that. That's fine. All right? The double quarter pounder with cheese is definitely an outlier. Okay? And the reason it's an outlier is because 43 is definitely bigger than 41. That's what makes it an outlier. So if we were looking at this and we were trying to go through and make the 5-number summary, which is your box and whisker plot. Sorry, I'm scrolling for a second. So, number line. All right. 5. All right, if we went through and we actually made this as a box and whisker plot and we're trying to show that 43 is an outlier, all right, I have my data set, 9, 21, 26, 29, 43. All right, so little line at 9. Next one is at 21, big line. 26, big line. 29, big line. And then 43 is way over here, and that's an outlier. All right, so little line, whisker. Most of the time you would just do this. However, depending on your calculator, you can actually plot it as a box and whisker plot where it will show you the outliers separated. Okay? And then basically 43 is your outlier. That frickin' double quarter pounder with cheese. All right. And if you want to see this as a box and whisker plot, you go up here to stat plot. We're going to mess with number 1 again. Oh, hey, look. It's a box and whisker plot. It's the 4th one. Oh, not that part. This one. All right. See how it's got the little dots? The dots mean it'll pop out and tell you, like, hey, we think these are outliers, but on a test, you're still going to have to prove it. If you go, well, my calculator gave it to me as a dot, be like, okay, prove it. We don't trust the thing that plays 8-bit Tetris. All right? The 5th one is them not showing it with an outlier. So here, let me turn on. Yeah, it's a normal box and whisker plot. Let me do it in red. On. He's boxing and whiskering. So, if you guys notice, the one in blue shows you 43 is definitely an outlier. What it does is it kind of ignores 43, and it gives you the whisker that matches without that 43 being in there. The one in red includes the 43, but it definitely shows like, hey, that whisker is way longer than it should be. Because that 43 is in the mix. Alright, Ryan? Yeah, so to graph it, you hit second, y equals. And then did you click which plot you wanted? Zoom 9. So you don't have this one? Or this choice? Okay. But does that make a little bit more sense? All right, cool. And I scanned the little sheet that I made on Friday, uploaded it, so you guys should have it. It is Manic Monday. So, hey guys, real quick, I uploaded the Idiot's Guide on how to make a histogram in here with all the buttons that you need to hit. Okay, and then I just kind of showed you with the same data that we did last week. If you make the X scale to be like 5Zs, this is what your little histogram will look like. Bueno? Bueno.